G'day guys, Isaac from Springer's Workshop here. Now, this customer came to us with the desire to go fully off-grid and wanting to run all of his usual household appliances that you would have in the creature comforts of your home. So we were only more than happy to oblige him with that. This van is definitely one of the coolest systems that I have had the chance to work on during my time at Springer's. We've kitted him out with all the bells and whistles. We've got big battery banks, huge inverters, a massive solar array, DC-DC chargers, AC chargers, the whole lot. So I'm really excited to run you guys through. And we've also got a couple of little secrets that we haven't really shown much on the program before. So I'm really excited to get into it. And we're just gonna go and check it out now, starting with the battery setup. So at the heart of every off-grid system, you have your battery bank. So for this specific installation, we've gone with two 600 amp hour lithium Enerdrive batteries. Now, a couple of reasons that we selected these specific ones for the job rather than any smaller size or an AGM battery is that we're going to be running a large inverter off it for prolonged periods of time because this specific customer would like to run his aircon. So for heavy discharges frequently, we're probably going to recommend lithium 9 times out of the 10. They just have a much deeper discharge and a faster recharge rate as well. So not only can they be drawn down further of their maximum capacity, but they can also recharge back up to 100% much faster than their competitors' AGMs can. They're also going to be considerably lighter in weight. To get the same amount of amp hours, 600 out of AGM batteries, you'd be looking to add about 150 to 200 kilos to your van. In proportion to that, you can get 200-300s of lithiums and it's going to add about 70 to 80. So literally 50% of the weight of an AGM with, in our opinion, bigger capacity, better recharge rate, and also a longer warranty period, which in my opinion is really attractive when you're spending big money on your off-grid systems. So parallel together 600 amps of lithium, which is more than enough to power this beast here, which is the 3000 watt Multiplus from Victron. So it converts the 12 volt battery power into the 240 output that you're gonna run all of your normal household loads off. Also a reason that we really like the Multiplus is that it comes built in with up to 120 amp AC charger. So if you're at a powered campsite, for example, or your mate's got a generator out, you can plug that into your input in the van, and not only will the generator or shore power supply your AC loads in the van, it can also charge your batteries at up to 120 amps per hour, which is way more than your average DC charger will be able to handle. Also over here, we've got the Enerdrive DC to DC, a very popular unit at Springer's. It's got the capability of bringing in vehicle charge from your start battery and alternator from the tow vehicle. And it also has a built-in MPPT solar controller. So in this instance, the customer's used it to plug in a portable panel on the exterior of the vehicle. So when he's driving to his campsite, it's charging these batteries from his alternator in this tow vehicle. And when he rocks up to camp, he'll put his portable panel out, plug the Anderson plug into the side, and it'll go through the same charger and charge the batteries that way as well. On this vehicle as well, we've got about 600 watts of solar, all running through a Victron SmartSolar charge controller. They're an MPPT brand, so they're a lot more efficient than the PWM solar controllers. They've got a 3-stage charging, so bulk, absorption, and float, so they're never going to overcharge your battery, always going to make sure that it's charged at the correct voltage for the correct amount of time and not damage it by under or overcharging. Also got a real simple fuse box there with AMI fuses, MIDI fuses, they're pretty popular, and a couple of blades off to the side. So you can also see for this system, we've mounted it under the bed, so as close to the front of the van as we can for better weight distribution. So you've got all your heaviest items, clearly your 2 batteries, the Multiplus, probably about 8 to 10 kilos just in that, and all your smaller chargers, we've mounted as far forward as we can, so the customer gets better weight distribution because he is a bit mindful of how much weight he's carrying in the van. Also, because this is going to be under the bed, you're obviously not going to be able to see most of this stuff normally, but that's no problem at all because we've got a Cerbo GX, which has a readout of the entire system, which is all you'll ever need to see and touch. Okay guys, so here is the Cerbo GX 70 Touch. Now, this is the brains of your system. This is the display of your system and the programming of it as well. This is probably 99% of what you need to get familiar with to be comfortable going off-grid in your system. You don't have to worry about anything we just looked at under the bed really, that will all look after itself. It is important for you to be all over what the monitoring of this means and viewing where your power's going so that you know what you're using, you know how much longer you've got, you know your battery percentage, all that kind of stuff. So we can see here that our battery's at 99% full at the moment. It's at 13.3 volts. We've just got a couple of LED lights on so that we can draw it down a bit to show you what it's about. This will be your solar input here, the little orange box. It's not putting in anything at the moment because the battery hasn't gone low enough for the solar to think that it needs to charge. We're going to turn the aircon on in a couple of minutes and see how much charge that rips out from your inverter. And then the solar will kick in once it realizes that the batteries are being quite heavily discharged, and it'll kick in to pump them back up really quick. So on the Cerbo GX touchscreen, you've got the red box at the top, which is your AC input. So that's a generator or shore power, which is coming into the Victron Energy Multiplus, which is this blue box in the middle. Currently says off because we've got the unit switched off. AC loads, so anything that's the Multiplus is powering. So it has the capacity to either draw power from your batteries, which is your blue box in the bottom left corner, or it can draw power from the generator or shore power and simply pass it through. So once we power either one of these up, little arrows is going to appear on these blue lines, literally showing you the flow of current and energy into your different appliances and how they're all working together to keep your system up and running. So now we're going to dive a little bit deeper into the monitoring and programming of the system. Nothing too difficult. We're just going to click on it and hit the menu. So this will take us out of our kind of general display, and we can actually select which Victron unit we want to look at more in depth. So we've got the SmartShunt, which is basically your battery monitor, where the battery tells us what percentage it's at, the time remaining, how many amps are coming out of it, what its discharge rate is like, everything like that. If you've got any issues with your system and you call us up, the first thing we're going to ask you is, what is your SmartShunt reading? We almost guarantee that we have to install this for every customer because it just makes diagnosis of any problem so much easier when you've got it all in one spot. So in the SmartShunt, you've got the state of charge right at the top, so 99% full at the moment. Consumed amp hours, so 5.7 amps consumed in this kind of cycle, you would call it. They've also got a time to go rating, so this is really important when you are off grid and you will literally need to know how many days or hours do I have left of this draw. So if you're drawing bigger than usual, it will reduce your time to go. If you're being quite conservative and getting lots of solar but not using any loads, your time to go will increase. So really useful to gauge how long you can go off grid for and maybe make plans to go to a caravan park or find a generator if you need to. Okay, so we've done the SmartShunt. Now we're back at the device list on the Cerbo GX. So the next one we're going to look at is the Multiplus, so 12-3120. We're going to click into that one. You can change the settings if you want to. You can set your input current limit, what state you want it in, the state of charge. We would set all of this for you appropriately if you did the system through Springers. If you are doing it yourself though, probably best to either contact a qualified auto electrician or check your battery discharge, check the Victron spec sheet. There is a lot of kind of different things that have to be set correctly for your system to work at an optimal percent. We're going to go into switch and we're going to switch the inverter on, which is going to bring the aircon on straight away. So we'll be able to see exactly what that's drawing. So we've gone from state from off to inverting. So the inverter is now creating 240 volts out of the 12 volts, which is exactly what we buy it for and use it for. So now we've got a DC current of negative 76 amps coming out of those batteries. So that alone is the reason why a lot of off-grid people are quite skeptical to run their Aircon Off 12-volt batteries, because it just draws a massive amount. If you only had, a single AGM battery, I don't even think this would last an hour. You'd maybe get an hour out of it if you're lucky running your aircon off it, but it would most definitely harm the battery, and yeah, heavily not advised for smaller battery banks. Okay guys, so we've switched the aircon on now. It is getting nice and cool in here, which is a relief for myself. Now we can see the battery's already come down to 98% rather than 99 as it was when we started. We can also see the massive draw of 1.1 kilowatts, and we're ripping out 87 amp hours out of these batteries. Bearing in mind they are 600 amps combined, so on paper you could maybe do this for 4 to 5 hours. Strongly not recommended by us though. It is a real big draw on the system. And as with any battery, it's not best practice to repeatedly rip massive charges out of it for a longer period of time. You can see here now that the Multiplus is inverting. It's no longer just turned off. So it's got power coming in both from the battery and from the solar charger, and it's going out to your AC load, which is obviously the aircon, drawing, as I said, just over 1.1 kilowatts. Your solar charger is only putting in about 300 watts at the moment because it can read that the battery percentage is still very high. So it's not utilizing the full 600 watts as it would be if the battery was, say, on 60 to 70%. So if we left this running and the battery discharged all the way to probably 70% of its full capacity, this solar charger would realize, oh, we've taken a massive amount of power out. We need to kick into high gear and utilize all of our watts that are on the roof. So at the moment, it's only using about 30% of the solar's capacity just to keep up with the aircon. Yeah, so we've just turned the aircon off now, guys. So the inverter is now off, no longer inverting. There's no AC loads, there's no incoming AC. So now it's just the solar, which as you can see is jumped up to more like 80% of its capacity, and it's pushing charge back into this battery bank. So we're putting in now about 30 amps an hour instead of taking out 80 with the aircon. So yeah, solar's been pumped up because the aircon stopped, and now it's going to recharge the battery, as you can see by these little lines going into the battery back there. Okay guys, so that was pretty much the full setup of the van that we walked you through. There's one more thing that we quickly wanted to touch on because it's something we get asked very frequently, and it's how much solar can I fit on the roof of my van? Now, this is probably the most difficult / important part of your entire system because it's limited by factors that we can't change or control ourselves, like what you got existing up there, aerials, aircon, roof vents, dust covers. There's all kinds of things that can impact where we can physically fit panels. So at the end of the day, that is most of the time the limiting factor is the physical space where we can fit panels, how big. So as a general rule of thumb, if you've got more space on the roof, you'll be able to have more charge going into your batteries, longer time off grid, and yeah, basically a better time away. We often get phone calls that people ask, oh, just straight out of the blue, how much solar can I fit on my roof? We really can't know that for sure. As a really rough guide, probably a minimum of 400 watts is what's considered the minimum, kind of normal. But to really say accurately and to give you some confident figures, we'd really either have to see the vehicle and measure it ourselves, or if you can jump up there and take a picture of the roof of it and any measurements that you've got, we can also size up some panels, what we think is going to work and fit there. Okay guys, so with that is the whole system done. Hope you enjoyed seeing that. I was really excited to be a part of that build, so I hope that you kind of learned a thing or two and got some ideas for your situation. Hopefully some of these ideas can roll over into the real world for you guys. Yeah, if you got any questions about it, drop it down below. We'll try our best to get back and answer them, or you can always call the store obviously and speak to one of our techs about it. Yeah, thanks guys. I'll see you next time.